Okay, so we're going to write and graph equations of lines. What form do you think we're going to use a lot? Slope-intercept form, absolutely, which is y equals mx plus b. What does m represent? The slope. Let's look at example 1. We're going to write an equation of the line that we see in the graph. All right, here's our graph. So we have 2 points, right? So do you guys remember what equation we used to find the slope? Absolutely. x2 minus x1. So here's our 2 points. So I'm going to use this one as my y2. So I'm going to say 4 minus a negative 2 over 0 minus 3. What's 4 minus a negative 2? 6, because a negative times a negative is a positive. Over what's 0 minus 3? Negative 3. Simplify, you get what for your slope? Negative 2. So now we just have to put this in slope-intercept form. So we say y equals, my slope is negative 2x. Now my y-intercept. First of all, you can look at your graph. Does it cross the y line anywhere? We're at positive 4. So I don't have to solve for it. I can actually just say plus 4. If you didn't see where it crosses the y line, then you would need to take your 2 points and plug one of them in here where the x and the y is to solve for your y-intercept. But since it's on the graph, we can just look at it. Any questions? Let's look at example 2. Write an equation of the line passing through the point negative 1, 1 that is parallel to the equation y equals 2x minus 3. What do we know about parallel equations? They have to have the same slope. So my new equation, I already know the slope, right? So all I need to find out is the y-intercept. So I just plug in this where my x and y are. So y equals 2 times negative 1 plus b. Now I can solve for b. 2 times negative 1 is what? Yep. So then to solve for b, I add 2. So I get 3 equals b. So my equation is y equals 2x plus 3. This equation is parallel to this other line, but it passes through this point. That's it. You can always check your work if you want to and graph these 2 lines on a graph and see that they're parallel. It's up to you. Any questions on writing parallel line equations? All right. Let's look at example 3. We're going to write an equation for a perpendicular line passing through the point 2, 3 and perpendicular with the line y equals negative 2x plus 2. What do we know about perpendicular lines? Remember the rule? The products of the slopes equal negative 1. So if I take negative 2 times the other slope, which I don't know, so I'm going to say m1, it's going to always equal negative 1. So negative 2 times m1 equals negative 1. So if this is multiplication, to solve for m1, I just divide by negative 2. So then the slope of the other equation, m1, equals 1/2. I'm going to teach y'all a trick. Look at this. You notice it's a negative 2. You can find the inverse opposite sign for the slope. Opposite sign makes it a positive number, right? Inverse of 2 is 1/2. All I do is make it into a fraction, which makes it 2/1, and I flip it. There is the same way to find the slope. If it's easier for you to do the math, please do it. But there's a quick way to find the slope of the second line. So now we have the slope of the second line. We just need to find the y-intercept. So I use my point that they gave me. 3 equals 1/2 times 2 plus b. 1/2 times 2 is 1. Subtract the 1. So b equals 2. So my new equation, my new line, is y equals 1/2 x plus 2. So that line will be perpendicular to this first line that they gave us. You could graph it and see it if you wanted to. Any questions? All right. Do you guys remember how to look at a graph and write an equation from it? Can I skip that example? If you see 2 points on a graph, can you write an equation, y equals mx plus b from that? Okay. So let's go to example 5. First of all, somebody tell me, what is standard form? Yep, we have gone over this before. If you do not have this in your journals, put it in there. Okay, you'll notice all it is the x and y are on the left-hand side with c on the right-hand side, which is just any number. So if I have, this is example 5, if I have 3x plus 4y equals 12, this is in standard form, correct? So I can graph this 2 ways. I can either solve for y, then I'll have the slope-intercept form and I can graph it, or I can solve for the intercepts. So I can find the x-intercept, that means where it crosses the x-line, and the y-intercept. Let's do it that way just for practice. To find the intercepts, you just plug in a 0 in the variable that you're not solving for. So let's solve for x. So I'm going to say 3x plus 4. Instead of y, I plug in a 0 there. So that cancels. Divide by 3. So I get x equals 4. So my x-intercept is 4. Now do it again, solving for y. I put a 0 where the x is. So that cancels. Divide by 4. I get y equals 3. So it's going to cross the x line at 4 and the y line at 3. So let's graph. So the x line was at 4. If I write that as a point, it'd be 4, 0. The y-intercept would be at 0, what was it? 3. Like so. So then you just graph it. X-intercept, I go over 1, 2, 3, 4. Y-intercept, I go 1, 2, 3. I missed. And then you connect the dots. You would have got the same line if I had solved for y equals mx plus b. So either way, unless it specifically tells you to solve using the intercepts, you can graph it either way. Any questions? Pretty easy for you guys. This is lesson 3.5. You're doing numbers 4 through 44, just the evens. No IXL for you.